Right, well, while I've got 5 minutes, I'm going to quickly modify this transformer. First thing I want is to take off the existing secondary windings, because at the moment I've got 60 volts, about 250 amps. Well, I want 1000 amps. So I'm going to show you guys today how I hack that secondary off and prepare it for new windings of 275mm. That big old cable on the secondary. I'll show you some 185. Right, well, this is 185, which is, as you can see, it's quite fat. And as I say, on that transformer I want 275, which is a lot thicker than this. So once I get the secondaries off of that transformer, I'll have quite a bit of room around the coils to put my new windings on it, and from that we should easily get 10,000 amps. So today, as I say, while I've got 5 minutes, I'm just going to hack off those secondaries and see what we get. So give you a quick close-up and then I shall get my grinder out. Well, firstly, these are the primaries, which are quite close to the centre coil. So I'm going to leave those. So basically I've got to take out these two, which are the secondaries. I'm going to leave these primaries there. Come around the other side. They're the secondaries, and I want all of those hacked out. It's quite thick wire, that. So there's a little bit of scrap copper there, but as I say, if I can get these out, look at it covered in cat's hair, then I'll have plenty of space to wrap the new cable round. Simple as that. So time to get chopping. Right, this is the first cut. It's the first layer of the secondaries I've cut. I've cut down both sides. So I'm now going to take that off completely. Right, as you can see, we've got 50% of these secondaries off. And at this stage, if I joined these two together at the bottom, I could have 30 volts out of these. Got quite some current, as you can see. A fair old bit there. But I'm going to take the whole lot off. As you can see, it gets easier when you start stripping it down. This next bit's critical because I don't want to damage the primary windings, but I want the secondaries off. And there's all the one layer of it over there. So this is really quite straightforward actually. It didn't take long at all. So I will carry on. Right, this transformer, all the secondary windings are now off that transformer. So I've just now got a 24 kVA transformer with a primary on it, which is quite heavy. And there I've just put some welding cable on there, which is only 35mm, just to see how many amps we can get and to check the phasing. Obviously I'm going to put some cable on there which is 10 times that diameter, so obviously we're going to have quite a bit of current. Let's see if I can sort those out and we get a current reading with just those. Just about to see that. Let's have a go. See what we get. Well, that's 600 amps just from that puny bit of wire, which is quite good. So I think we're going to have a bit of fun with that. Lots and lots of amps. Let's show you around the other side of that. So obviously we've still got our primary there, but no secondary. So there's our primary. And that wire, as I say, is just a temporary test, just to check what we've actually got. So that is looking good. That is going to be one monstrous transformer. that will kick out guaranteed 10,000 amps or more easily. And we've got 24 kVA there, and that's actually being driven on a variac at the moment because it's okay to do that providing it's under no load conditions, or you know, not too heavy. So I'm very pleased with that so far. Well, that job was extremely easy, and we've seen now how easy it is to get a decent sized transformer, as I say, 24 or 20 kVA, whatever that is. Rip out the secondaries, leave the primaries where they are, and you know, that welding wire there is just a quick test, just to check that I've got both coils in phase, because if you get them wrong, one will just cancel out the other and you'll get no volts. But that's the way I'm going to wind it, but obviously with wire which is 10 times that thickness, flexible wire. And I shall put some great big lugs on the end, 10,000 amps. But what will make it more interesting is to have some real man's diodes. These diodes take loads of amps. 4 of these, and I should be able to run 1,000 amps DC with these. Bit pricey, all good fun there. So I'll give you a close up on them if I can. Right, well these are the diodes. As you can see, these are quite heavy duty. These can take 7,500 amps surge, which is quite significant. And obviously with 4 of those, that'll be a full bridge rectifier. And I think we're going to have some serious fun with them. These were about 70 quid each. They are nice though, look at them. RS components. So there's 2 of each. 2 anode stud, 2 cathode stud. I shall make a nice bridge rectifier up, terminating with this copper bar. And we're going to have an awful lot of fun now, I think. But yeah, as I say, there's the transformer. The primary's totally intact, but I've got to get some wire which will be 10 times this thickness at least, and we'll wrap that around it a few times to do it properly and nicely. And that will probably be railway cable, which will be rated at 650 volts, cross section where we are probably 275mm, which is about 1 inch. The cable's about 1 inch diameter total, so I'll probably get quite a few turns of that, and that will be absolutely awesome. That will turn that into a proper high current transformer. My clamp meter won't be able to register it. It will be well over 10,000 amps, which is quite a lot. This bit of bar, that will just glow red and pop like a bit of 5 amp fuse wire on a cooker, and that's what we want. Of course it is. I don't think these diodes will take that much, but we'll see on that. There's quite a bit of current there already. We have another little burn with it. Right, at the moment I'm just putting in 120 volts into the primary. As you can feel that there. Now I can use the variac to control that, so I'll crank it up a bit more. So you still have control through the variac, but with loads of amps. That at the moment is pulling only 100 amps. So let's short it out some more. That's better, isn't it, eh? Ooh, that's nice. We've got molten copper there somewhere. Where's my fire extinguisher? And that cable is just a tiny fraction of what we're going to get. Boys and girls, until next time, play safe.